It's not sufficient to just assemble a large number of machines to do a particular task. You actually have to figure out, how do I divide that task effectively across those multiple machines? So a number of companies that built up data centers in the late 90s and early 2000s were facing this problem. They had data centers, they had lots of machines, they had big jobs that they needed to do, like building search indexes, crawling the web, but there was this question of, how do I split those jobs up? And what emerged out of that challenge was a programming model that was quite popular. It's still in use today, although I think we're starting to develop some more sophisticated alternatives. But it's something known as MapReduce. And so I want to talk a little bit about MapReduce because it's a pretty important part of how search was done for a long time. So MapReduce is a programming model. It's a way of structuring your computation that allows it to easily be run on lots of machines. So the way to think about it is, you have a job to do. If you organize your job in a particular way, if you organize your computation in a particular way, then it's very easy for that computation to take advantage of huge numbers of machines. So I write my job using the MapReduce framework, and then if I have 100,000 machines available, I can run my job potentially on 100,000 machines. So that's pretty cool. That's a nice thing. Let's talk about how MapReduce works. So MapReduce forces you to break what you're trying to do into 3 stages. The first is map. The second is a shuffle stage. And the third one, as hinted by the name, is reduce. Let's talk about how map, shuffle, and reduce work. And let's do that in the context of the most famous MapReduce example of all time, even if it's kind of dumb, which is this idea of, how would I count the number of times that a word appeared in a document? So I've got let's say I've got 2 computers, but this example should scale to larger numbers, and I have 4 documents. Okay, here's document 1, document 2, document 3, document 4. But you can imagine I had 1 billion documents and 100,000 computers, and this still works. That's the beauty of the MapReduce framework. The first thing I'm going to do is I'm going to divide the documents between the different computers. So I'm going to assign these 2 documents to this guy, and I'm going to assign these 2 documents to this guy. And now, so this is the map phase. And what each computer is going to do is it's going to produce a count of the number of times that a particular word appeared in the documents. So, what I get out here is I might get something, I get a key value, I get a set of keys and values, and the key might be the word cat appeared 10 times, and the word dog appeared 3 times. And in these documents, the word cat appeared 24 times, and the word dog appeared 5 times. Obviously, this is a cat-loving set of documents. Okay, so these are computed by these computers. And again, the nice thing about the map phase, or the way the map phase has to be set up, is there's no no communication between these machines that's allowed during the map phase. So the machine just processes the documents it's given. So if I have 100,000 documents and 100,000 computers, each computer processes 1 document. If I have 1 million documents and 100,000 computers, each computer processes 10 documents. So I process my documents, and now what I do is, in the shuffle and the sort stage, I take these keys and so now I have 2 more machines that I'm going to use in the reduce stage, and these could be the same machines, or they could be different machines. It doesn't matter. What the shuffle stage is going to do is it's going to sort these keys so that the reduce stage gets the same key. So in this case, this reducer is going to get all the cat keys, and this reducer is going to get all the dog keys. And all I do in the reduce stage is I take the results from the map stage and I combine them together. So map is the process of splitting all the inputs among a bunch of machines, and then reduce takes the results from the map stage and combines them together to get the one result that I'm looking for. So in this case, what I would do is I would combine cat and cat, so 10 plus 24. This reducer would produce cat 34, and I've got dog 5 and dog 3, so this reducer would produce dog 8. And then I'm done. So now I have what I wanted, which is a key value map of the time that every word in these documents appeared. The nice thing about MapReduce is that the programming framework on some level is fairly limited. It's quite structured. It forces you to to set up your computation in a way that it can be done on many machines, but it's also fairly restrictive. There are certain types of computation that don't fit very well into the MapReduce framework. And as time has gone on, people have developed more powerful frameworks that to some degree are generalizations on top of MapReduce. They make MapReduce more powerful. They give you more than just map and reduce. They give you more features. They allow the nodes to do more work. But this idea of creating a programming model that allowed you to easily use hundreds of thousands of machines is a very powerful one, and it's one that we see over and over again today.